actually a nicer notation for nested if statements. Here is an example. So as you can see, it has a bunch of column headers and a bunch of row headers and a bunch of expressions in the content cells. And what this means, and the whole thing, right, if you start selecting, the whole thing is an expression. You can see we add to the points variable this whole expression, and it works the following way. It evaluates the column headers, and then it evaluates the row headers, and for each combination, if this column header is true and this row header is true, then the value of the expression is this, and so on. If this is true and this is true, then that's the return value. So in other words, if let's say the altitude is 3,000 meters and the speed is 180, then the value of this thing would be 20. And of course, here you can have arbitrary expressions, right? You can have arbitrary Boolean expressions here. You can also see how we use the physical units and how the whole thing is embedded in a component. We hadn't explained these extensions yet. We'll do that in separate videos, but you can see how these various extensions can be extended and combined. Now, if you look at this decision table, you may perhaps notice something if you look closely. And so as you perhaps notice is that for altitude equaling 2000, both of these columns are true. In other words, the decision table is undecided. It's not consistent. It's not, completely clear which of the two, or well, 4, depending on the speed, values would be valid. So let's see. We can mark this table as verifiable. And if it's verifiable, we can select the table and verify the decision table using the menu action here. And let's see what happens. So we run the verifier. And what we get is a bunch of things. One is the table seems to be complete. That means that for all possible values of altitude and speed, we have actually made a decision. However, it is also inconsistent because the cell 11 and 21 are inconsistent. That is, of course, because here, you can have, it's undecided what happens if you do 2000. So let's change this to just bigger than 2000 and rerun the decision table. Then what you should get is that everything is consistent. So as you can see, this is already the first extension that benefits from formal verification. You can verify any decision table that is verifiable, and you just toggle verifiable. Let me show you a problem. Let's change this to, let's say, make this So now we have a problem. First of all, okay, the type system complains if you have altitude times altitude, you get meters squared, so this doesn't work. But let's see, if we mark this as verifiable, then we should get yet another error that says only linear expressions are supported in verified decision tables. The problem is this here, squaring the altitude, is not linear, and the SMT solver can only do linear arithmetics. So if you want your decision table to be verifiable, you are somewhat limited with regards to the expressions you can use here. But the good thing is the IDE tells you directly, and you can make a conscious decision whether you want your decision table to be verifiable or whether you want to use all of C. So if you remove this, you get back to the verifiable state, no error, and you can run the verification. And I probably didn't say that, but of course you can also add additional columns and rows to the table. It doesn't have to be 2.